Hey guys, welcome to Distance Learning Geometry. We are going to be doing a little different concept. I figured it would be easier to do over distance learning. We're going to kind of step away from the shapes, the triangles, the parallelograms, quadrilaterals, and that kind of stuff. And we're going to talk about some things that I actually really enjoy. We're going to talk about probability, statistics, and set theory, which has to do with geometry. It's not totally inside the geometry realm, but it is a part of what we're going to learn this year, or this term. So we're going to talk about set theory today. And basically what set theory is talking about is it's just a set of things. Like the even numbers would be a set of numbers. It's the numbers that are divisible by 2. The multiples, numbers that are multiples of 3. So 3, 6, 9, 12, 15, that's a set of numbers. This applies to things other than numbers. And so what we're going to talk about today I thought would be fairly appropriate. Let's imagine that we have a box. Okay? So I'm going to draw the box. Okay? This box is full of Christmas ornaments. Okay, and what we're going to talk about is the sets of different things. Now, there are things inside this box that are not what we're looking for. Let's say there are 3 criteria that we want to put on our Christmas tree. We want red and green ornaments, so that's one set of things. Okay, so I'll draw a circle, and that'll be, we'll call that set A is the red and green. So A is red and green ornaments. Let's say we also have some light up ornaments. Okay, so we'll draw that circle right here, and that'll be set B, and set B equals the ornaments that light up. Okay, and then C is the set of, we'll do that right here. And C can be the set of all the ornaments that maybe are shaped like snowflakes. Now you'll notice inside this box I have an area that's outside set A, B, and C. That would be the example, that would be the ornaments that are neither red or green, don't light up, and are not snowflakes. So there's stuff in the box that don't necessarily line up with any of our sets. Okay, anytime we're talking about something that doesn't line up with what we're looking for, that's known as the complement. Okay, that just basically means that it is something outside. And when we say that, let's say we want to talk about the complement of A. Well, the complement of A would be all of the ornaments that are not red and green. So all the gold ornaments, all the blue ornaments, all the ornaments that were not red and green, we would write either it's a little squiggly mark A, this is the symbol for complement, a little squiggly mark, or we could also write A with a little C up above it right here. Both of these symbols represent the complement, and all that means is the set that is outside of A. Now, and that's the complement. Now, there's also something that's known as the universal set. And it's just basically a big crooked U. Okay? The universal set is everything in the box. So if you hear the term the universal set, all that means is everything. Now, with what we're going to be doing for these couple of days, we're going to be talking about sets of numbers. They may give you a random universal set of like the numbers 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The numbers 11 through 20. That would be the universal set. And then there will be sets like the even numbers or the numbers that are divisible by 6 or different kinds of sets like that that will be smaller sets inside the bigger box. So think of the box that everything is in as the universal set. And remember, the sign for the universal set is just a big crooked U. So on the worksheet that you have for this first assignment, one of the things that in the box over the side It asks for the universal set. I think it's number 4. That answer is the big crooked uppercase U. That's the symbol for the universal set. Okay? Now, let's talk about some other concepts based on these sets that we have. So the universal set is everything. The complement would be everything that's outside of what I'm looking for. If I'm looking for the complement of A, B, and C, then I could just write the complement of A, B, C, and that would be everything in the box that's outside all 3 of my circles. Now, what if we want to know what's inside all 3 of my circles, A, B, and C? That's where we talk about the union of A and B. It looks very similar to the universal set, except it's kind of straight up and down. It looks almost like a half of a paper clip. So anytime we're talking about the union of 2 sets, it's both A and B. So this terminology right here is the union of A and B, which means everything that's inside my A circle and my B circle. Okay, so the U-looking symbol on your worksheet in the little box over to the right means I'm talking about both A and B. Or if I was talking about everything that's in B and C, I could say B union C, and that would be everything that's in circle B and C. So going back to, let's say we have the numbers 11 through 20, and we're looking for the union of the even numbers and the numbers that are divisible by 6. Well, that would be 12, 14, 16, 18, and then also 12 and 18. So those numbers would be the union of those 2 sets. Okay, so it's everything that is in both of those. Okay? Now, let's talk about the intersection. Anytime I want to do the intersection of 2 things, it's very similar to the union. That's why the symbol is very similar, except it's flipped upside down. Instead of the skinny U, it's the skinny U upside down. This means the intersection of A and B. That's talking about all of the parts that are right here in both A and B, but they have to be in both. That's why it's called the intersection. Okay? And that's what this symbol means. Anytime you have the U upside down, the skinny U upside down, that means the intersection of those 2 sets. Okay? And that's simply meaning that. Now, if it were the intersection of A, B, and C, that would be this little bitty part right here in the middle, which is the only spot where we have ornaments that are red and green in a set A. They also light up, and they're snowflakes. Okay? So if I'm specifically looking for those specific ornaments that are red and green and light up and are snowflakes, then that would be the intersection of set A and B and C, which would be this little, and this is known as a Venn diagram, whenever you draw it out to make it make more sense. So if you see that on a worksheet, it's just talking about the diagram where you draw circles to see where the different sets overlap. And you can, when we have numbers, you can draw a Venn diagram and then write all the numbers that go inside of A and inside of B. That would be the intersection, and so on and so forth. Okay? So that's the union and the complement and the difference as well as the intersection. Let's talk about a subset. Okay? And that would not actually apply to this, but let's go back to our set of numbers that we talked about. So let's go back to our numbers. We had the numbers 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, let's say set A is all the even numbers. Okay, so that would be 12, 14, 16, 18, and 20. So I can write, well, I'm gonna hold off on that. Okay, but I also said that I need a set of the numbers that are divisible by 6, which are just 12 and 18, right? In that set. So, what are my numbers that are in set A, but also in set B? Well, set B is just 2 numbers, 12 and 18. But then set A, we've already got 12 in there, so we've got 14, 16, and 20. And then we have all the other numbers, 11, 13, all the odd numbers, 15, 17, and 19 on the outside. Okay, so what we would say about set B right here, which is the numbers that are divisible by 6, right? Set B would be called a subset of set A because all of the numbers that are divisible by 6 are also even numbers. Okay, so this is a smaller set that's inside of our bigger set. So we would write B is a subset of A, just like that. It's the same U, but it's turned on its side, basically meaning that this is a subset, or it's a set inside the bigger set, okay? And then these numbers out here would be the complement of set A. So 11, 13, 15, 17, and 19 would be the complement, meaning they're the numbers that are not even, that are in our universal set. And then this would be the universal set, okay? If we're writing something in set notation, we just write, let's say it's set A, and then we use squiggledy parentheses, and then we write out all the numbers or all the things that are inside of our set, and then we close those squiggly marks. So we would do that to say that. If we're talking about the number of items, so how many numbers are in our set? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So that means we would write n of A, the number of items that are in set A is equal to 10. So anytime you see an n with parentheses of A, and actually it's usually a little n. I wrote that wrong, I'm sorry. So little n, the number of the items that are in set A is going to be 10 because there are 10 numbers. Okay? Numbers 9 through 13 on the assignment from today are just simply, you're making up the sets. So when it says the number of elements in set D on number 10 is 5, then you would just write little n of set D equals 5. You don't even have to write the set, you just write the notation. And then it says the universal set is all the odd numbers from 10 to 20, so that's where you would write the big squiggly U, and then write out all the odd numbers between 10 and 20, and so on and so forth. Okay? If you have any questions, again, I will be on a Google Meet on Thursday to answer any of your questions. I will also answer any emails, and if we need to set up a time to talk to explain this in a little more depth, if something doesn't make sense, then I'd be more than willing to do that tomorrow, Wednesday, or Thursday, or Friday. Whenever you have questions, just email me. Hope this quarantine or distance learning finds you good. Stay safe, stay healthy, and I'll see you when you get back.